Hi everyone. Today we're going to study addition and subtraction of unlike fractions, meaning these are fractions with different denominators. In this video, we're going to study two methods. The first one is the conventional method. The second is the crisscross method. Let's begin with the conventional method, where we are going to have three steps. The step 1 is to find the least common denominator. Step 2 is we convert each fraction into equivalent fraction having LCD as the denominator. And step 3, we add or subtract the equivalent and eventually like fractions. Let's see example 1. Add the following: 2 over 9 plus 1 over 6. Step 1 says we find the LCD. First, we're going to list all the denominators here. Then take the prime factors of 9. That will be 3 times 3 or 3 squared. The factors of 6 as 2 and 3. Then we're going to collect all the factors. I start with the number 2 and then the number 3. But there is number 3 with highest power, so I will copy the highest power as the rule says. Then we will simplify this 2 times 3 squared, and that is equal to 18, and that is our LCD. Step 2 is we're going to convert the fractions into equivalent fractions, having LCD as the denominator. Look at the 2 over 9. What we want to do is this number 9 to be equal to number 18. And we're going to multiply this number 9 with a number to get a product of 18. On the same way, this number 6, we want to make this 18 by multiplying by a certain value. As we see here, the 9 must be multiplied to 2 to get 18. The 6 must be multiplied to 3 to get 18. Then, that same number 2 that we multiplied to number 9 must be the numerator. So this must be 2 over 2 because this is equal to 1, and the number 1 multiplied to any fraction will not change the value of the fraction. The same way with the number 6 multiplied by 3, and then the numerator we must write 3 also. So the 3 over 3 that is equal to 1 is multiplied to 1 over 6. So the first fraction becomes 4 over 18. So we multiply 2 by 2 becomes 4. We multiply 9 by 2 becomes 18. The second fraction becomes 3 over 18. Because we multiply 1 by 3 becomes 3. 6 times 3 is 18. So now we have equivalent fractions here. Then in the step 3, we're going to add now the fractions. Eventually they are now like fractions. So the final answer is 7 over 18 because 4 plus 3 is 7, and then we copy the common denominator. Let's have the second example. Subtract the following fractions: 7 over 18 minus 1 over 12. So for step 1, we'll have all the denominators listed. Then we will factor out 18 into 2 times 9, and that 9 is equal to 3 squared. We factored out 12 into 4 by 3. but the 4 can be written as 2 square. And then for the LCD, we list all the factors. For some common factors, we're going to write that factor with the highest power. So for number 2, 2 square is the highest. I will copy here 2 square. For number 3, 3 square is the highest power, so I'll copy the highest power, 3 square. And then we simplify this. This 2 square is 4, this 3 square is 9. We multiply 4 by 9 equals 36. So for step 2, we are now to convert the fractions into equivalent fractions. We want to convert this 18 into the LCD 36, so we multiply 18 by 2. So in here, it is 2 over 2. On the second fraction, the 12 must be multiplied by 3 so that it will get 36. So this fraction is 3 over 3. Then we simplify. The first fraction becomes 14 over 36 because 7 times 2 is 14. Of course, 18 times 2 is 36. Then minus. The second fraction becomes 3 over 36. Then step 3, we simply subtract 14 and 3 equals 11 over 36. Let's see this example number 3. This time we have 3 fractions here. 1 over 9 plus 2 over 15 minus 1 over 6. Step 1 says, let us find the LCD. 9, 15, and 6. The factors of 9 is 3 square. The prime factors for 15 is 3 and 5. The prime factor of 6 is 2 and 3. Then, for the LCD, we list all the factors here. I start with number 2, followed by 3, but since the highest power is 3 square, I wrote here 3 square, and then 5 is also listed. Then we simplify this into 90. So our LCD is 90. Now we're going to convert these fractions into equivalent fractions using the LCD of 90. So the 1 over 9, we multiply this 9 by 10 to get 90. This 15, we will multiply by 6 to get 90. This number 6, we will multiply by 15 to get 90. So the 10 here, there must be a 10 also in the numerator. Here 6 in the denominator, another 6 in the numerator. Here 15, another 15 in the numerator. So this one becomes 10 over 90. This fraction here becomes 12 over 90. This fraction here becomes 15 over 90. Then we go to step 3. We are now to operate all the numbers in the numerator. So the 10 is here, 12 is here, 15 is here. Of course, the signs or the operations here is plus. This is minus. All over 90. And we simplify all to be 7 over 90. Let us consider now this second method. We call this a crisscross method. So given a fraction a over b plus or minus c over d. The steps are, at first we're going to multiply a and d. So that is AD. Next, we put the sign. It can be plus or it can be minus depending on the operation. Then we multiply B and C. As you see here, it's BC. And then, in the denominator here, the b and the d is multiplied, and we put that as the denominator here. And the step 2, we need to reduce the fraction to lowest term if possible. So from our conventional method, this is the same example, 2 over 9 plus 1 over 6. We solved that in our previous example, and this is the answer, 7 over 18. So I'm going to put this answer on that side here, and then we're going to solve this using the crisscross method. So we multiply 2 by 6, becomes 12, plus, then we multiply 9 by 1, becomes 9. Then we multiply 9 by 6, becomes 54. We write in the denominator. And the sum is 21 over 54. Then we go to step 2. We will reduce to lowest term. We will think of a number that can divide both the numerator and the denominator. And we have the number 3. So we divide 21 by 3, we will get 7. We divide 54 by 3, we will get 18. As we see here, we have the same answer with the conventional method. Let's have another example. This is coming from the same example in the conventional method, the 7 over 18 minus 1 over 12. We solved that a while ago. The final answer is 11 over 36. So I'm going to put this 11 over 36 aside. We are going to solve this now using our crisscross method, and we expect to have the same answer here. I multiplied 7 and 12, I get 84, minus multiplying 18 by 1 is 18. Then multiply 18 and 12, I get 216. Then the difference on top is 66 over 216. Then we go to the step 2 to reduce this to lowest term. So the number 6 is the number that can divide both the numerator and denominator. So 66 divided by 6, I get 11. 216 divided by 6 is 36. And we have the same answer with our conventional method a while ago. Let's have this third example. So we have a mixed fraction plus a fraction plus a proper fraction. At first, we need to convert the mixed fraction to improper fraction. So this 1 and 2/3 is equal to 5 over 3. Then I copied the 1/4 here and the plus sign. Then I will start my crisscross method. 5 times 4 gives me 20, plus 3 times 1 is 3, then 3 times 4 is 12. Simplifying the numerator, I got 23 over 12, or the mixed number of 1 and 11 over 12. Thank you for watching. Watch out for more math videos. See you next time.